Spaceship left the solar system in 2012. The spaceship left the solar system in 2012 and is currently more than
18 miles from Earth.
This marks the first time we have been exploring this new region of space, interstellar space, far in the cold, quiet corner of our solar system, where the sun's light barely reaches. Voyager 2 still talks to Earth. It has shown us new worlds with amazing pictures and facts. But recently it sent a weird, jumbled signal that NASA can't explain. It's not a broken part, it's something from somewhere else. The signal suggests that the solar system's edge hides something old, complex, and maybe even smart, making us rethink what's out there. The unexpected signal Voyager 2 has been speeding through space for over 45 years, traveling more than 34,000 miles per hour. It is one of NASA's most trusted space explorers, quietly sending back valuable data from places far beyond our solar system. For decades, it has delivered steady updates, plasma readings, magnetic field information, and cosmic ray data. Even though its technology is old, it has worked far better than anyone expected. But recently, something strange happened. NASA's Deep Space Network, which keeps in touch with Voyager 2, noticed a problem. The system that helps the spacecraft stay pointed at Earth, the attitude, articulation, and control system started acting weird. Suddenly, Voyager 2 was sending its data through a computer on board that had been shut down for decades. That old computer wasn't meant to be in use anymore, and the data coming through it became scrambled and unreadable. Oddly enough, Voyager 2's signal was still strong. It was still pointing toward Earth, which meant the spacecraft itself wasn't broken. Nothing mechanical seemed wrong. So what was going on? The stranger had got at first, engineers thought it was just a malfunction. But the more they looked into it, the stranger had got. No one on Earth had told Voyager to reroute its data. It had done it on its own, and in all its years in space, Voyager 2 had never done anything like this before. That's when the question changed. Instead of asking what was broken, engineers began wondering why the spacecraft had switched to a dead system. When they dug deeper, they made an even more surprising discovery. The messed up data wasn't just random, it had a pattern. It looked like something from Voyager's earliest days, as if the spacecraft was remembering its first launch instructions. Even weirder, hidden in that data was a soft, low-frequency signal that repeated every 7.4 seconds. NASA engineers started calling it the heartbeat. This heartbeat didn't match anything Voyager 2 had been programmed with. It didn't come from any part of the spacecraft that engineers could identify. In fact, it didn't seem to be coming from Voyager at all. It looked like it was coming from somewhere outside the spacecraft that changed everything. Maybe this wasn't just a glitch. Maybe Voyager 2 had picked up something in space, something trying to communicate, or something influencing its systems in ways we don't understand. Some experts thought it might be a software issue, like a ghost in the machine, but others weren't so sure. The signal was too steady. To exact the edge of the helipause, Voyager 2 is now about 13 billion miles away from Earth. That's not just far, it's almost hard to imagine. Since November 2018, it has been floating outside the sun's protective bubble, known as the heliosphere. Out there, in what scientists call the interstellar medium. Voyager 2 is surrounded by a strange and quiet world filled with cosmic rays, bits of ionized gas and magnetic fields from faraway stars. It's currently in the part of the sky we call the constellation Pavo, because of its distance. Any signal Voyager 2 sends back to Earth takes over 19 hours to reach NASA's listening stations. Even though the spacecraft was launched way back in 1977, nearly 5 decades ago, it's still working. It gets its power from special devices called radioisotope thermoelectric generators. These are slowly running out of juice and are expected to stop working around 2028. But until then, Voyager 2 is still doing its job, sending valuable information about the space beyond our solar system. As it moved near the helipause, the wild and messy edge where our sun's solar wind clashes with the space between stars, it picked up a structured signal. The helipause isn't a clean border, it's a chaotic region with shifting magnetic fields and changing plasma densities. When Voyager 2 crossed it, one of its instruments noticed a sudden spike in plasma density, confirming that it had entered true interstellar space. But the real mystery is the strange signal. It hints that something unusual may have happened. Almost as if Voyager 2 was scanned or briefly interacted with by something unknown. This is different from what Voyager 1 experienced in 2012, which had a smoother crossing and didn't pick up anything similar. Voyager 2, on the other hand, still has more instruments turned on, including a magnetometer and a cosmic ray detector. These tools picked up signs that suggest an outside force may have responded to the probe's presence. Scientists don't fully understand what caused the signal. Some think it could be natural, like a plasma wave bouncing around the helipause. Others wonder if it's something even stranger, maybe a structured energy field reacting to Voyager's arrival. Some recent research suggests that the helipause could actually shape or change signals that pass through it, like a natural amplifier. So maybe the signal was always there. Voyager 2 just happened to catch it at the right moment. Quiet. Guardian. Watching Voyager 2, most people think of space exploration as something flashy, rockets launching, astronauts floating in zero gravity, or rovers exploring distant planets. But behind the scenes, there's a lesser-known hero quietly keeping things running, NASA's Deep Space Network, also known as DSN. It doesn't make headlines often, but without it, we wouldn't be talking to Voyager 2. The DSN is a global system made up of 3 massive facilities located in California, Spain, and Australia. Each site is home to enormous radio dishes, some as wide as 70 meters. It's designed to catch even the faintest whispers from space. And when we say faint, we mean it. Voyager 2's signals are so weak that they register at just a billionth of a watt. Yet, thanks to the DSN's precision and persistence, we're still able to hear from this 48-year-old spacecraft. Recently, DSN engineers spotted something strange. Voyager 2 began sending corrupted telemetry data, and instead of following its usual pathways, some of that data was being rerouted through an old, dormant onboard computer. Even more curious, the spacecraft appeared to be emitting a rhythmic signal described as a heartbeat that didn't match any of its known systems. This odd event was later classified as Event F2X, and details about it have been tightly controlled. The engineers at the DSN were the first to detect this anomaly, because the network is constantly monitoring and analyzing incoming data. They quickly noticed that something didn't add up. Using their knowledge and tools, some of which are nearly as old as the spacecraft itself, they managed to partially restore communication. But this strange rerouting raised a bigger question. What else could the DSN be missing? Maintaining contact with Voyager 2 isn't easy. The spacecraft is nearly 5 decades old and runs on technology that would seem ancient today to read its signals. Engineers sometimes rely on outdated software and hardware tools they've had to maintain or even rebuild from scratch. And the fact that the Earth rotates, and it becomes clear why the DSN has antennas spread across the globe. As our planet spins, the network hands off communication duties from one site to another, ensuring constant contact with our faraway probes. Decoding the message, NASA eventually came forward with an official statement explaining that a telemetry error had caused the recent issue with Voyager 2. They claimed the problem was fixed by simply rerouting the data through the proper systems. But what NASA didn't say publicly is what they discovered when they took a deeper look at the original corrupted signal. Using Voyager's old communication software, the kind originally designed, decades ago, engineers uncovered something strange. Inside the messy stream of data were binary markers that didn't come from Earth, nor were they part of Voyager's internal programming. When these markers were mapped visually, they formed a pattern, hexagons inside other hexagons, repeating again and again. It was a design that seemed familiar in nature, but felt out of place in a machine-to-machine communication system. Some engineers said it reminded them of crop circles but written in the language of computers, while others compared it to fractals, mathematical patterns that repeat on different scales. These shapes and sequences were not normal for space. Probe transmissions, even stranger were the timestamps connected to the data packets. It didn't line up with Voyager's current clock. It was like the data came from a different point in time altogether. One NASA insider reportedly described the signal not as an error, but as a message that changes everything. It raised new questions. Was it a natural phenomenon that mimicked intelligence? Or was it something truly intelligent trying to communicate? The Zone of Echo, a small team of scientists, started to explore a bold idea. What if this wasn't a malfunction at all, but a kind of response? Something replying to Voyager's signal. It proposed that Voyager had crossed into an area at the edge of the solar system where signals could be absorbed, changed, and then sent back in a new form. The binary code might not be a glitch. It could be a structured reply. What made it more mysterious was that the response came through a computer on Voyager that hadn't been active for years. It was as if something or someone had turned it back on to start a conversation. This led to a dramatic new theory: the region near the helipause, the border, where the sun's influence ends in interstellar space begins, might not be just a boundary. Some started to think of it as the Zone of Echo, a quiet zone between different realms of space. According to this theory, the zone is not only silent, it listens. And when something like Voyager enters, it answers. NASA's public stance stayed quiet, but behind the scenes, everything changed. The Deep Space Network tightened its communications. Scientists working on decoding Voyager's data were suddenly reassigned, and independent researchers were told to stop discussing their findings in public. Internally, NASA began referring to the situation as Event V2X. It was no longer treated like a technical hiccup. It was now a matter of national and scientific sensitivity. Mysterious shutdown in March 2025. NASA made a quiet but important announcement. It had shut down Voyager 2's low-energy charged particle instrument just a few months earlier. October 2024, the plasma science instrument was also turned off. Both decisions were explained as necessary steps to save power and help extend the life of the spacecraft. Voyager 2 runs on a type of generator called a radioisotope thermoelectric generator, or RTG for short. These RTGs work by using the heat from decaying plutonium to generate electricity, but there's a catch. They lose about 4 watts of power every year. It means the spacecraft has to be very selective about what instruments it keeps running. Now, only 3 are still active: the magnetometer, the cosmic ray subsystem, and the plasma wave subsystem. NASA's Jet Propulsion Laboratory says these choices are practical and necessary. Their goal is to keep Voyager 2 operating well into the 2030s, and that means preserving just enough energy to keep its most essential systems alive. In fairness, these remaining instruments are still collecting valuable data from a region of space. No other spacecraft has reached the space beyond the sun's protective bubble, known as the heliosphere. Still, not everyone is convinced the story ends there. The timing of these shutdowns has sparked a lot of questions. After all, Voyager 2 is currently in interstellar space, where every bit of information it sends back could teach us something entirely new. The low-energy charged particle instrument was designed to measure particles like electrons and ions, while the plasma science instrument helps scientists understand how charged particles move in space. These tools played a major role in confirming Voyager 2's dramatic exit from the heliosphere back in 2018. So why shut them down now, when they're still functioning, and the data they collect is more valuable than ever? Critics argue that it doesn't make sense unless there's more going on than NASA is letting on. Some theorists believe NASA might be hiding something. They point to past moments when the agency was slow to release data during strange events, and they wonder if Voyager 2 might have recently picked up something unusual, maybe even a signal or energy pattern that didn't match what scientists expected. The idea is that, instead of dealing with the public confusion that such a discovery might cause, NASA chose to quietly power down the instruments that could detect it. There's also the question of power management. In 2013, NASA found a clever way to tap into Voyager's backup power reserves to keep things running a little longer. So why not do something similar now, instead of turning off key instruments? If the spacecraft is still functional and the instruments are still working, why not squeeze out every bit of data possible? Voyager 2 saw Uranus's magnetic storm. NASA's Voyager 2 spacecraft did something no other probe has done before. since it visited Uranus. This distant ice giant sits nearly 3 billion miles from the Sun, way out near the edge of our solar system. It's cold, quiet, and mysterious out. They're close to the boundary where our Sun's influence starts to fade into interstellar space. Because of its location, Uranus offered a rare opportunity to study strange space activity far from Earth. Voyager 2 flew by Uranus just once, but what it found has puzzled scientists for decades. One of the most surprising discoveries was the planet's magnetic field. Voyager's magnetometer showed that Uranus's magnetic field wasn't like anything seen around other giant planets. It was tilted at a crazy 59 from the planet's spin axis, and it wasn't even centered properly. The north and south axis of the magnetic field was tilted by almost 60 relative to the spin axis of Uranus. That's strange. It's created a lopsided, unstable magnetic bubble around the planet, known as the magnetosphere. Even weirder, the magnetosphere seemed to be collapsing or twisting in on itself. Magnetic field lines were tangled, bent, and squeezed. Plasma wave instruments detected sudden bursts of charged particles flying around, and Voyager picked up strange radio pulses that didn't follow a steady pattern. Scientists think this might have been caused by a strong solar wind hitting the planet, or maybe something going on deep inside Uranus itself, like changes in the core's magnetic engine. This all added up to one thing: Uranus was not calm. Unlike Jupiter or Saturn, which have large, stable magnetic fields, Uranus looked like a world caught in the middle of a magnetic storm. The spacecraft also discovered 10 new moons and several thin rings during the flyby, showing that the planet was full of surprises. Because Uranus is so tilted, it basically rolls around the Sun on its side. Its magnetic behavior may be more sensitive to forces from beyond the planet. Some scientists have even wondered if the odd magnetic shifts Voyager 2 saw were caused by something more than just solar wind. Maybe, they suggest, it was a weak cosmic signal or some sort of external force briefly interacting with the magnetosphere. Voyager's data hint at the possibility that places like Uranus, near the edge of the heliosphere, could be more easily influenced by galactic forces, maybe even something artificial. Lost for a week recently, NASA lost direct contact with Voyager 2, one of humanity's most distant explorers. This happened after a small error. A command sent from Earth accidentally turned the spacecraft's high gain antenna just too off from its alignment with our planet. 2 may sound tiny, but in deep space, it's enough to lose a signal that was already incredibly weak. For a spacecraft that depends on sending soft whispers of data across billions of miles, this slight shift meant Earth could no longer hear it. So, how did this mistake happen? The error came from Earth. NASA sends regular commands to Voyager 2 to update its systems and operations. These instructions are crafted with extreme care, but even a tiny mistake like a wrong number or an unexpected signal delay can cause miscommunication. In this case, it appears that a command sent during routine operations unintentionally tilted the antenna. That means it was a human error, one small instruction that had a big impact. And since Voyager 2 is over 13 billion miles away, fixing that mistake is far from easy. The disruption left NASA's Deep Space Network with radio dishes located in California, Spain, and Australia unable to pick up Voyager 2's usual stream of data. Instead, all they could detect was a faint carrier signal picked up by the Canberran station in Australia. This signal was proof that Voyager 2 was still alive and still traveling through interstellar space. But the signal was too weak to carry any real data. NASA couldn't read its instruments or send new instructions. It was like hearing a voice on the other end of a phone call, but being unable to make out the words. Suzanne Dodd, the Voyager project manager at NASA's Jet Propulsion Laboratory, pointed out that after 47 years in space, Voyager 2 remains surprisingly tough. But without a properly aimed antenna, the team can't guide it. NASA is now trying to shout a command using the DSN in hopes that Voyager 2 will catch it and realign its antenna. The challenge: the signal takes 19 hours just to reach the spacecraft, and another 19 to hear back. If that plan doesn't work, there's still a backup. Voyager 2 is programmed to reset itself in October 2025, using the Sun and a bright star called Canopus to reorient its antenna toward Earth, but the silence is unsettling. Voyager 2 isn't just any spacecraft, it's the only active probe we have in interstellar space. It's exploring the edge of the heliosphere, where the sun's influence ends and the unknown begins. Losing contact now, just as it's flying through this mysterious frontier, feels oddly timed. It makes you wonder, where are its signals going now? They're still being broadcast, just not toward us. Could they be drifting into areas of space we don't understand? Could something or someone out there be picking them up? NASA says this is just a technical hiccup. But the urgency of their response definitely means that Voyager 2 might be detecting something strange. The Golden Record. Voyager 2 is also important because it carries the Voyager Golden Record, a gold-plated copper disc made as a special message from humanity to any extraterrestrial life that might find it. This time capsule was launched in 1977 under the guidance of Carl and is meant to share the story of Earth with the universe. The record holds 115 pictures, greetings in 55 different languages, sounds of nature like ocean waves and bird calls, and 90 minutes of music from classical Beethoven to traditional Senegalese drumming. It's all protected by an aluminum cover and even includes a stylus and instructions for playback. The record wasn't just a random collection. It was carefully designed as a message for any aliens who might come across it. It even includes a map, made with pulsar-spinning stars that act like cosmic lighthouses to show exactly where our solar system is in the galaxy. While the sounds include everything from a mother singing a lullaby to the haunting calls of whales and the rumble of thunder, it's a beautiful snapshot of Earth. This contrast between the probe's fading ability to communicate and the enduring presence of the Golden Record makes you wonder, during the times when Voyager 2 falls silent, could its message be picked up by something unknown?